Hello everyone. This is Team 8 and our project is CrimeXplorer. Uh, our project is built upon the premise that there's a lot of crime in the society and people need a tool to help them navigate around the surroundings. Basically tell them where there is a lot of crime in society, what are crime hotspots and what aren't. So people can know where to go and where not to. That's essentially helping people uh, around their surroundings.
Also, this will also help in decision making whether which society to choose in. We're moving in from different states in the United States itself, so it can be a decision point of view also that this place is safer and this is not. So people can make decisions based on that.
Yes.
So we have solved this problem. We have the data set for New York from NYPD and the Arizona state data apart and the California state LAPD data also. So we have created all of this and we have created an ontology in the Prodigy tool. We have used Apache Jina Fusiki server to map our ontologies and host it. And
Yeah, we've created Spring Boot APIs to which we essentially write Sparkle, which have Sparkle queries in them, which are getting these instances from the Fuseki server, and then this is basically becomes an endpoint for our front end, which is built in Next.js.
Yeah, so the front end is built in Next.js, and the basic libraries we have used is a basic UI library which is Bootstrap to get all the components, all the fancy components to make our UI look a little better. And apart from that, we have used the Leaflet library. So it's a library which we can use a map, and in that map we can pinpoint or mark like a pin or a heat map kind of thing, a circle. So it's an interactive library that is based on actually the world map.
So let's look at our firstly our Fuseki server. This is our this one query that we've tested that we're using. This essentially gets 10,000 queries, 10,000 instances from our hosted ontology. For example, this has starts with Arizona over here. And if I just write in the search, there's California as well. There's New York data as well. So there's about 10,000 instances over here. It's getting the entire data that we have in our entire database, mixture of all of them essentially.
Yeah, so the number of triplets that we are using is like over 4 lakh, and we have limited the query to only 10,000 so that our the front end is not getting over the memory use is not getting and it might crash. So we have limited that to only 10,000.
Yeah. And as for the benchmark used for experiments, we have basically written JUnit test cases to test our code against, and that worked perfectly. We've also tested our code base, an application against a given set of queries, that is 10,000. It takes 10,000 is a good number for giving the application enough time to load. Beyond that benchmark, our application basically the load time is high, so that is the benchmark that we've set for our application to load all the data and display the details whatever you want to show you in the final demo presentation right now. So that is about our Fuseki server and all the data and triplets in it. Next,
so yeah, we have created the crime data set in the Fuseki server itself, and the rule set that we have created from the Prodigy itself. So it was exported. The file size was around 50 MB, and we have hosted the same in this. We have created this crime endpoint, and all the calls are made from this only. So this is hosted on EC2 instance, and yeah. So structure. Yeah. Sorry for that. Yeah.
I'm sorry for that.
And yeah, project structure is so this is our backend. It's a Spring Boot application. It runs on Apache Tomcat 80 port. This is a front end code. Like it's very basic to test out the queries and
yeah, so let's just go through our front end right now. When you open a front end application, this is the main home page that you come to. And let's go through all the tabs that are there in our front end application. First, this is the crime by location. Essentially, it gets out all the crimes that we have. It calls the API that I told we created that gets all the
the
crimes.
backend API in the Spring Boot.
So since we have,
it takes a time to the map to get populated because
there are about 10,000 instances coming out from
so it takes a little bit
Ziggy
time.
server. So yeah, there's data in California, Arizona, as well as in New York.
The blue tip that you see is the location of this current system. So if you click on, so these are interactive. If you click on any of the tooltip, you can see what exactly the tooltip is all about. So if you click on this one, so this is the blue one is the current location of the user, and if you click on any of the red one, so it states the state in which the crime has happened, the distance from the user. So you used the distance calculation, the ever sign formula.
Exactly, and yeah, and so that's what all the data is, and we have also provided 3 buttons to filter out the data. Example, if you just want to see the crimes that happened in Arizona, click on this button over here, and it just shows the crime that happened in Arizona. And then basically that's how you can filter on. Similarly with California, if I click California, same with the New York button over here, so you get all the crimes by location. So heat map is one thing that we were working on, and it was kind of like not done, but yeah, one sec. So that heat map was an extra feature that we couldn't get working on, but our main goal is done and sort. And that is our application. And I guess you need to explain the Prodigy class and object also once. So Prodigy classes, we have the crime, person. Person has 2 subclasses, perpetrator and victim. Then there's location, city, county, lat, long, street, and zip code. So the person is connected to the higher ontology level as the DBPDI person. DBPDI person as suggested by Dr. Bansal. Okay. And so this is the basic classes that we have in this, and there are the object properties for the corresponding classes. So it has like crime involved, has location as its subsections like the county, city, and the state. The has person has perpetrator or victim, like based on what the person is, and the data properties are as follows. So has age, contact info, is victim, is perpetrator. So basically from the last deliverable, only change we have made is the attaching the classes to a higher level ontology. Which is the person, DBPDI person class. So individuals, we use this selfie plugin. We use the selfie plugin to load the to generate the actions. We created transformation rules at first. Then we generated the actions for that. Rule that we push the actions onto our ontology. Then essentially what we explained previously is hosting the ontology on the Fuseki server and then accessing the Fuseki server through our Spring Boot API application. So that's about the gist of our entire application. It's functioning, all that stuff. So concluding, like we can quickly conclude. So the individual team contribution, I would say that we all have worked in each and every aspect of the application, but okay, let me tell you about what each and every person of our team specifically worked on. Myself, Karthik, I worked on creating the loading the instances of firstly Aman Ramani worked on creating the ontology. Then myself, I worked on adding the data set onto the ontology using the selfie plugin. So myself is Preet. So I did the most of the front end stuff and the integration of that back end and front end, and all the infrastructure work was done by Aman and Siddharth, and Aditi were responsible for the documentation. So each one of us had the whole idea of what actually is happening and the whole aspect of the application. And essentially, it's not just one person that did one piece of thing. There were times when I was stuck with my laptop was slow and I was not able to get the transformation rules generated and unable to generate the axioms for loading the instances onto the ontology. Then Aditi helped out and she did the rest of the part. And there were times when Ishpreet was stuck on creating the front end, and then I helped on it and adding more functions onto the front end to filter the data, fix this errors, all that stuff. So it was essentially a team project, and this is our end application. So, hope you liked it.
Yeah. So that's it.
That's
Team,
it from
team 8 signing off.
Team
So
8 signing
that
off.
was our presentation.
That
Thank
was
you.
the presentation. Thank you.